This question is to calculate the correlation coefficient between two dependent variables within a repeated random experiment. Please subscribe to our YouTube channel Math Tutor 8285. Your subscription fuels the passion. Let's grow together. Thank you so much. A random experiment has three possible and mutually exclusive outcomes, labeled A1, A2, and A3. Each outcome occurs with equal probability of 1/3. The experiment is repeated independently 2 times. Let x be the number of times outcome A1 occurs, and y be the number of times outcome A2 occurs. What is the correlation coefficient between x and y? There are 4 options. First step is to understand the distribution. Each trial produces exactly one of the 3 outcomes. Since the trials are repeated independently 2 times, x, the number of times outcome A1 occurs, follows a binomial distribution with 2 trials and success probability 1/3. Similarly, y and z, which count the number of times A2 and A3 occur respectively, also follow the same type of binomial distribution. Note that even though x, y, and z are each binomial, they are not independent because only one outcome happens in each trial. This dependency matters. Next step is to use the relationship between x, y, and z. In each of the 2 trials, only one outcome occurs. So across both trials, the total number of outcomes must be exactly 2. That means x plus y plus z equals 2. This lets us express y in terms of x and z. Y equals 2 minus x minus z. This identity is crucial for finding how x and y relate. Next step is to calculate the covariance between x and y. We want to compute the covariance of x and y. Using the earlier identity for y, we substitute covariance of x and y equals the covariance of x with 2 minus x minus z. Now we apply the linearity of covariance. The covariance of x and a constant like 2 is 0. The covariance of x with itself is just the variance of x. So we get covariance of x and y equals 0 minus the variance of x minus the covariance of x and z. Here's the key insight. By symmetry, the covariance of x with y is the same as the covariance of x with z. So we can replace the covariance of x and z with the covariance of x and y again. Now we solve. Covariance of x